Imagine this. You are watching a movie or playing a video game where the heroes are on a quest. They are heading toward their objective and realize that they need to go on a side mission to get a key, find a map, or win some tokens. Think of a JavaScript function as that side mission. And if you recognize this place or the movie it was in, drop a comment. Here's a hint. The buildings sitting on this hill in the movie were removed after filming. Here is the path of our primary quest, otherwise known as the main flow of the code. When the browser processes this code, it runs it from top to bottom. We now realize that we need to generate a random number for our game. So we go off on a side mission in search of that random number. And when we've completed our task, we return to the main quest with that random number. How'd that metaphor work for you? Make sense? We use a function to go off and perform a subtask and then return with the result. Let's break down the syntax for a JavaScript function. Like a side mission, the purpose of a function is to perform a single task. In this example, the task is to generate a random number. We declare a function using the function keyword. We give it a logical name describing its purpose. Like variable names, we use camel case notation, meaning the first word is lowercase and each appended word is capitalized. Don't use spaces in a JavaScript function name, and consider avoiding dashes and underscores as well. The function parameters identify the information that must be passed into this function. Think of the parameters as placeholders for the information the function needs to perform its task. We can provide any number of parameters, separated by commas. If the function doesn't require any passed-in information, we leave the parentheses empty. Name the parameters using the same naming convention as variables. Use meaningful names and camel case. A function body is denoted with curly braces. Inside the function body, we add statements to perform the required task. In this example, we use one of JavaScript's math functions to generate a random number between 1 and the defined maximum number. This code needs a little debugging, which we'll do in the upcoming demo. On most side missions, we return with something, and functions are the same. We optionally return the result of our task. In this example, we return the generated random number. A function declaration is not part of the main flow of the application, so code in the function is not automatically run when the web page is loaded. We need a way in our main quest to break off into our side mission. We do that by calling the function. The function code runs when the function is called. We call the function using the function name, followed by parentheses. If the function has parameters, we provide the data, called arguments, for each of those parameter placeholders. In this example, we pass in 20. The 20 fills the max placeholder and is the value used wherever max is referenced. If the function returns a value, we can assign that return value to a variable. Want to try it out? Let's create and call a function to generate a random number for our game. Here we are again in VS Code with our Guess a Number folder open on the left and our page running in the browser on the right with the developer tools open. Before we begin, let's clean up our code for our game and delete the middle two variable declarations. Now let's declare our function. I like to put my functions at the bottom of the script file after the main flow of the program. Or you can put them into a separate .js file, especially if they'll be used by multiple script files. Start with the function keyword, then a meaningful name. We'll go with generate random number. It's a longish name, but it's descriptive of what it will do. The function requires parentheses after the name and curly braces to define the function body. As a block statement, it doesn't need a semicolon at the end. But we will need a semicolon on any statements within the function body. If we want to pass any information into the function, we define the parameters inside the parentheses. These are placeholders for the information that will be passed into the function when the function is called. In this case, we want to pass in the maximum random value. Do we want the user to guess a number between 1 and 10, 1 and 20, 1 and 100? By making this maximum a parameter, we can adjust the number range whenever the function is called. We'll name the parameter max, but we could be more verbose and use max guess or something similar. Inside the function body, we want to perform a required task, generating a random number. JavaScript provides a math object with a random method, so let's use that. Use let to declare a variable called result, and set it equal to math dot. Notice how VS Code helps us see the list of math methods. There are a lot of them. We want random. This is a method, so we call it using the method name immediately followed by parentheses. We end this statement with a semicolon. And since we are in development, let's display this value in the console. Recall how we do that? We use console.log. We'll pass it a label for our logging information and the result. Lastly, we return the generated number using the return statement and a semicolon. Notice in the browser that we don't see our message. That's because the code in this function is not run until we call it. In our main flow, we'll call the function. We first declare a variable to hold the result. We'll use const because we don't want to change the random number once it's set. And let's call it random number. We assign this variable to the result of our function by calling the function. We specify the function name and parentheses. Our function has a parameter placeholder, so we pass in an argument to assign to that parameter. Let's go with 20 to allow guesses from 1 to 20. Now we see the generated random number here. That's an odd number. It turns out that math.random generates a random number between 0 and less than 1. We want it to be 1 to 20, so here in our function, let's multiply that random value by our max parameter. Looking at the browser, that number is bigger, but no user is ever going to guess that number. Let's click refresh and see what other numbers are generated. The numbers appear to be in the correct range, but we need to round it off. The math object has a floor method that returns the largest integer less than or equal to the number, basically dropping any decimal places. Let's go with that. We want a new result, which is the math.floor of the original result. We pass in the original result as the argument to the function. In the browser, click refresh a few times. That random number is looking better. We can clean up this code by putting this syntax directly in as the argument to math.floor. I'll cut it from here and paste it in here. Then delete the leftover declaration. And we'll change this declaration to a constant, since we shouldn't change the random number once it's set. Are we there yet? There is one more problem with our code. Any guess as to what it is? Let's refresh the browser a few more times and watch our results. Notice that we never see 20, and we are seeing 0. The game is supposed to allow guesses from 1 to 20, but it's generating numbers from 0 to 19. That's because math.random always returns a value less than 1, and the math floor always rounds down, so it will never make it to 20. To fix that, we'll add 1 to the result. Now let's see how we did. Refresh the browser a few times, watching the random number. We should get a 20, but not a 0. We now have a random number generator function we can use in our game. Cool! And we've learned some techniques for finding and fixing logic errors in our code, also known as debugging. Let's leave our setup the way it is and head back to the slides to learn about arrow functions. There may be times we want a shorter syntax for our functions. For example, take this simple function that doubles a value. With arrow functions, we write this function like this. Notice that it takes 1 line instead of 3. It's called an arrow function because of the arrow operator here. How do we get from this typical function expression to the arrow function? We drop the function keyword, drop the function name, drop the parentheses, place an arrow after the parameter, remove the curly braces, and remove the return keyword. But this syntax only works if the function body has one statement. If there are multiple statements in the arrow function, we still need the curly braces and the return keyword, as shown here. Arrow functions aren't particularly useful as reusable functions. Because they have no function name, we can't call an arrow function. Rather, arrow functions are useful when we pass a function to another function. We'll see that later in this course. So, use a function to define code for a specific task, a side mission if you will. Declare the function with the function keyword, a meaningful name, and parentheses. Define parameters within the parentheses if this function needs data to perform its task. Separate multiple parameters with commas. Use curly braces to define the function body and add statements to perform the task. Optionally return a value to the calling code. An arrow function is shorthand syntax for a function declaration. But since it doesn't have a name, it's most often used when passed into another function. To run the code in the function and perform its operation, call the function. Use the function name, add parentheses, define arguments within the parentheses to pass data to the function. Optionally assign the result to a variable. Best practice is to use a function for every task that our page needs. Then our main flow assigns variables and calls these functions as needed. Each function should have one clear purpose, and its name should reflect that purpose. Functions provide better code organization. The functions are then reusable for any page that links to the script. And because the code for each task is within a function, it's easier to find, modify, and maintain that code over time. Now that we've covered variables, if statements, and functions, let's talk about variable scope. You can't have a function without fun. If you agree, please like and subscribe.